how tough it is for some reason for a Tuesday to feel like a Monday. Okay, I will stop complaining. And let's get to it. Any questions before we get started? Are we good? Okay, and being advanced algebra, a full week's worth of material in an hour and 15 minutes. So yes, it will feel overwhelming, but the parts that you zone out for, because you know you're teenagers and you zone while adults are talking to you, go back, watch the video. Yeah, and if you want to see this year's video, then send me an inbox message. I'll send you the link because the video on there is last year's video. Okay, let's get started. Oh, no worries. We are just starting. Welcome. Okay, number one, we have a rule, and I can explain why the rule. I can explain, everything has a why. It's not just math teachers got together, wave our magic wands, and say, let's make this rule. There's a reason. Okay, I can explain the reason, but we're just going to show the steps at this point. So the rule, I'm the only one that calls it this, is no radicals in the basement. Okay, no radicals in the basement of a fraction. No square roots in the denominator of a fraction. So we're going to go through all this work to get rid of this radical, unless you happen to notice something about rad 4. Does anyone notice? Is anyone happy when they see that there's a 4 underneath? Ding, ding, ding. Anyone else? What do we notice about 4? The number 4. 4 is a perfect square, right? So that's just 2. So rad 5 over 2, done. Didn't have to do anything. Yeah, thank you. Perfect square. Okay, moving on. Okay, this is where I start to act like I don't know what I'm talking about, because I'm actually doing the same thing in advanced algebra. And if you had me last year, we did this in geometry. I believe it was geometry. We did one. Okay, no radicals in the basement. Yeah, but I have a radical over a radical. If I have an inside number over an inside number, I can actually reduce those. That was a very fat pen. Okay, so if you have radical over radical, you can reduce inside number with inside number. That would be rad 7 over rad 1. Radical 1 is 1. I don't know if that helped. Okay, so no radicals in the basement. Can I reduce a 5 and a 2? No. So this is what you do. You're going to multiply by bottom over bottom. Bottom over bottom. Okay, if you have a 5-year-old in the room and they hear me say the word bottom, they're going to be like, hee hee hee. Okay, so you're going to multiply. Now notice that just equals 1. You're multiplying by 1. You can, thank you. You can take a fraction and multiply by 1 and it does not change the value. So what do I mean by bottom over bottom? We're going to take rad 2 over rad 2. Okay. So bottom over bottom, rad 2 over rad 2. The whole goal is to get rid of the radical in the basement. So we have inside and inside rad 10 over rad 4. Now you're going to be tempted to cancel that down to 5 and 2. Resist. Yeah. No. No. Sorry. Okay. Don't reduce that into 5 and 2. But so right now we're at this place, rad 10 over rad 4. Does anyone like the fact that it's a rad 4 on the bottom? Because rad 4, because 4 is, yes, a perfect square. So now we have rad 10 over 2. We like when there's perfect squares on the bottom. So now we have a question. Can I reduce an inside 10 with an outside 2? No. 10 is inside, 2 is outside. Yeah, done. Okay, you do this one, please. Multiply by bottom over bottom. So I'm going to multiply by bottom over bottom. I just multiplied by a form of 1. I did not change the value. Okay, what do we have on top? I have an outside 7 and an inside 3. You're going to have to make a decision. Do you combine? Can you multiply an outside 7 and an inside 3? No, you cannot. 7 rad 3. Okay. So you're going to, I will not always be with you when you're doing these problems. You're going to have to remember, do not multiply the outside 7 with the inside 3. But now we have inside 3. So we have 9. We like the number 9. We like rad 9. Yeah, because the square root of 9 is, ding, 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 3. So now we have a choice. We have a decision to make. Can I cancel an outside 3 with an inside 3? And do you see what I mean by outside 3 and inside 3? Yeah, 1 is inside the square root and 1 is not. Can I cancel those 3s? Nope. This guy's done. The 3 on top is inside, the 3 on the bottom is outside. Okay. So things are going to come up and you're going to need to know how to use these radicals. Okay, distribute please and see what you get. Okay, so we have inside 6 and inside 3 is 18. Outside 3, inside 6. Okay, let's check the chart of factors. 18. I wonder if there are any factors that are perfect squares. Check the 18. That needs to go away. Okay. Okay. 18. There we go. You guys are faster than me. 2 and 9. Okay, so 18 is perfect square and leftovers. And we like the number 9. 9 is a perfect square. 3 red 2 plus 3 red 6. Okay, so the next step, can I combine these? I have 3. The number 3 is how many you have. I have 3 red 2s. And I have 3 red 6s. All together, can I smush them into something? No, when you add, they have to match. That guy's done. 3 red 2s, 3 red 6s. Oh, okay. You could, they have a GCF. You could factor that out. But yeah, so know that these are equivalent. If it's a multiple choice, you might see either one. Okay, but you could leave it that way. So either way. If it's just write the answer. Now, don't take the extra step and make a mistake, because then you took a step you didn't have to take. And you ended up losing points. Can we divide instead of distributing? No. You might be, no, you can't divide. You have to multiply and distribute. Okay. Let's come back to this one at the end, and then we can talk about that idea of dividing. Okay. Now let's talk about end behavior. If you were with me last semester, then you have seen this idea of end behavior. It looks like this guy. It looks like that guy. Okay, this is what you will have on the test, but what does this mean? So y equals, it's the parent graphs. Y equals x squared. Exponent of 2 makes a u. This is a happy u. Happy. Oh, by the way, everyone, happy Valentine's Day to everyone. Happy Valentine's Day. This is a happy u, and this is a sad u. With the negative in front, it's sad. Now, what if there are other numbers, not just x squared? Then it's not sitting on the vertex. So if there's other numbers, it just gets moved, but notice, has the same shape. Okay. Let's talk about the x-intercepts. This one has an exponent of 2. It hits the x-axis one place, and it is a bounce. Okay, this one has 2 x-intercepts. If I were to factor, split, and solve, I could find the 2 x-intercepts. So exponent of 2, you're expecting 2 x-intercepts unless you get a bounce. Here's another bounce. It has an exponent of 2. It only has 1 x-intercept at positive 3. It has a bounce. Notice +3 is the only x-intercept. Okay. You're like, back to the packet, almost back to the packet. Exponent of 3. Yeah, you take the parabola, the positives go up, the negatives go down. If I put a negative in front of the exponent of 3, it flips it. Flips it. Negatives go up, positives go down. Hopefully this is familiar. Now, what happens if I add plus 2x squared plus 5x plus 17 or something? I made up those numbers, right? Look how it changes. The end behavior still looks the same, right? The middle behavior changes. The end behavior stays the same, the middle behavior changes. So, do you see what I'm trying to say? End behavior stays the same. Middle behavior changes. Okay, x to the 4th looks like this. If I add more, end behavior stays the same. Middle behavior changes. X to the 5th. Negatives go down, positives go up. The biggest exponent is odd. End behavior stays the same, middle behavior changes. Okay, going back. So we're going to use words. Okay, your turn. Exponent of 2 makes a u. On the left, is it going to rise or fall? On the right, is it going to rise or fall? So what are the 2 words that I write in here? All right. Rise, left, rise, right, because the parent graph looks like that. Does that make sense? We are ignoring all of this. Exponent of 2 makes a u, rise left, rise right. A little bit of a tongue twister here. Okay, how about this one? Sketch a little parent graph and fill in the blanks. Look at so we're going to look at this negative x cubed. Negative x cubed degree 3, right? So there's our parent graph. So it looks like this. Okay, so what did you say? Down? Rise. Left. You could either say down or fall. Right. Yeah, we're getting it. And you will have that chart. Use the chart. Okay, number 6. Notice no negatives. Correct. Anyone else? So it looks like this, right? Fall, left, rise, right. Okay, number 7, on your own. Funny thing is, it takes me as long to write on your own as it does to give the answer, but I want you to do number 7 on your own, or stick around at the end and we will talk about it. Okay. We're not going to deal with fractions at the moment. So we're going to change this to -1, +2. This is a challenging problem. Write a polynomial function of least degree, meaning there could be others. We are not writing the only one. There could be others. Okay, write a polynomial on this. We're going to assume that a equals 1. We're not plugging in a point to solve for a like we will later. Okay, so the 0 is -5. The factor is x. Am I going to change the sign or am I going to leave the sign? Does it have the fractions? Okay, cross off those fractions. We're going to do -5, -1, and 2. Yeah, okay, I'm sorry. Cross off the fractions. And I want to do -5, -1, and 2. The fractions add one more step and we shouldn't have started with it. Sorry about that. Okay. So when the 0 is -5, the factor is x plus 5. When the 0 is -1, the factor is x plus 1. When the 0 is 2, the factor is -2. Okay, we want a polynomial, which means we have to multiply these together. So we're going to grab these two. You can grab what other two? We're going to grab these two and we're going to make a box. Okay, multiply those together, please. Or make a diamond in your head. So this is x squared plus 6x plus 5. Thank you. Nice. Okay. Now focus on this. I need to multiply these. So what is the answer to all our problems? Make a box. What are the dimensions of that box going to look like? Another box, correct. The answer is always another box. Now, technically, it looks like it needs to be a 3x2. I don't like making, oh, I could do a 3x2 right here. You could either do 3x2 or 2x3, depending on what space you have. So I have x squared plus 6x plus 5. Notice, outside edge of the box, right? Don't put those inside. We are multiplying. When we multiply things, we put them on the outside edge. X squared plus 6x plus 5 times x minus 2. Okay, multiply. X cubed minus 2x squared. Don't peek at mine. Now check mine. Did I make any arithmetic errors? Which I do that sometimes. And the more tired I am. Okay, good. Thanks. Okay, next. Combine like terms. Final answer. X cubed plus. How many x squareds? 4. 4x squared minus how many x's? 7. 7x's minus 10. There is our polynomial with no worries, with zeros, -1, -5, -1, and 2. Okay. Reach your hands above, get some oxygen going to your brain before we do the next step, the next problem. Okay. Find the zeros. Take the f of x, replace that with a 0, and solve. Okay, think about what we're going to do to solve. I'll be right back. Okay, I can either factor, split, and solve, or do quadratic formula. Let's see if we can factor. How can I check to see if I can factor this problem? Before the box. Good, that's a good guess. The answer, okay, right. So first we're going to do the rainbow. So rainbow, diamond, box. I need 2 numbers that multiply to get 10 and add to get 11. 10 and 1? Yeah, 1 and 10. Okay, now we're going to do the box. Two x squared and 5. Okay, what's going to go diagonally? Ten x and 1x. Thank you. Okay, GCF of the top row. The only thing they have in common is x. Factor the box. X times 2x is 2x squared. X times 1, 2x times 5. So bring it down. Don't forget the 0. 2x plus 1, x plus 5. Thank you. Are we done? No. Problems are getting longer. Factor, split, and solve. 2x plus 1 is equal to 0. X plus 5 is equal to 0. Ooh, yeah, but we want to find the zeros, so we're going to have to split and solve. Subtract 1. 2x is equal to -1. Divide by 2. X is equal to -1/2 minus 5 and -5. There's our answer. Okay. Next. This is, I'll give you a hint. You're going to have to use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. You need to do this on your own or stick around at the end and I'll do it for you. And they're going to come out square roots. Let's do this one. Okay. X equals -b plus or minus the square root of b squared. So -3 times -3 is +9, right? A negative times a negative is a positive. Minus 4ac all over 2a. Okay, so I kind of skipped over something. Let's see if we can factor number 11 and do it just like we did number 9. Do the rainbow, 2 numbers that multiply to get +8 and add to get -3. Are there 2 numbers that multiply to get +8 and add to get -3? No. So this is not factorable. So that's why we have to do quadratic formula. And I didn't explain that part. Okay, next question. Should this right here be 9 squared? Should that be 9 squared? No. Do we see that I squared the -3 to become 9? Yeah? Are you with me? Okay, good. Okay, next step, simplify this. 9 minus 32 is 23. -23. Okay, don't leave a negative number underneath the square root. It becomes an imaginary number. So -23 is -1 and 23. 23 is prime. It does not have a factor that is a perfect square. Okay. Something over 4. What goes on top? Three, plus or minus. What comes next? Thank you. I read 23. Okay, so is that not as bad as when we practiced a week ago? A little bit better? Yeah? Okay, good. Okay. Number 12. So number 12, write a function in factored form. We don't have to do those boxes. That will produce the graph. Okay. So parent. What degree, a little, okay, I'll take it. What degree function is this judging by the parent? X squared, negative x squared, x cubed, negative x cubed. What is the exponent? What is the degree? Correct. Yeah, anyone else? Y equals x cubed. Got that from that chart. Okay. Now, x-intercepts. X is equal to -4 and x is equal to 5. Wait, but it's exponent 3 and I only got 2 intercepts. What shall I do? What shall I do? I'm expecting 3 intercepts. It's exponent 3, it's cubed, but I only got 2 intercepts. What went wrong? Oh, thank you. Oh, wait. Okay, this one is going to be x minus 5. Everyone see that? Yeah, we're going to change the sign. Something funny is going on here. This is a bounce. When it's a bounce, it's a little mini parabola, right? So this is x plus 4 squared. Yeah, it's a bounce. It bounces on -4, so it's a little mini parabola. So here we go. Y equals a x plus 4 squared x minus 5. So -4 is a bounce. +5 is a regular 0. So I can leave it in factored form, but I need to solve for a. So we're going to grab this point right here. We're going to plug in 0, -8. So what? No, sorry. -8 is equal to a. 0 plus 4 squared, 0 minus 5. I plugged in. I could plug in any of these points, but you like plugging in the y-intercept because then you have x equals 0. Simplify. -8 is equal to -80 a. You with me? Yeah. 16 times -5. Yeah, Zoomers, are you with me? You see where I got the 80? Okay. Okay, divide by -80. A is equal to 1/10. So here we go. Y is equal to 1/10. X plus 4 squared, X minus 5. Okay. Are we good? You don't like it, but it makes sense. Here's the deal. On your next exam, it will be, and we're going to call this degree 3, right? Which comes from the parent graph. That's the one you're going to need to do on the test. It is kind of complicated. Now, this one is degree 4. We're going to skip that one. Okay. Yeah. Well, it's important to see the little mini parabola because you know that's where the bounce is. Yay. Okay. It's the degree 4 is not that much more complicated, but if you want to see it, yeah, 12 will be different numbers, but 12 will be. Okay. 13 degree 4, it won't be a degree 4, it'll be a degree 3. If you want to see me do this one, stick around, we'll do it at the end. Next, possible rational zeros. Now, let's go over here. X squared plus 7x plus 12. What are the possible rational zeros? Can you see that I'm talking about the factors of 12? The possible rational zeros, and I'm going to make a diamond, right? But they could be plus or minus 3, plus or minus 4, plus or minus 2, plus or minus 6. Now you're thinking, why did you include the 2 and the 6? Okay, once we get the 7, we know it's the 3 and the 4, right? But the list of possible rational zeros, it could also be plus or minus 1 and plus or minus 12. Once you make the diamond, you're going to narrow it down and find out exactly which pair works. But 3, 4, 2, 6, 1, 12 are the possibilities. Okay. Now, this is what you're going to do. Notice we have a number in front, complicates things. So we're going to do P's over Q's. The P's are the factors of 1. The Q's are the factors of 2. So this is laying a foundation. Some of you are going to be in math analysis next year, taking this pre-calculus, and this is kind of, it'll be more important for next year. We're not going to, anyway, it becomes interesting. So the P's, what are the factors of 1? Positive 1 and negative 1. The Q's, what are the factors of 2? Positive 1, negative 1, positive 2, negative 2. So when you see the phrase in the directions, possible rational zeros, you are going to think P's and Q's shake hands. P's and Q's shake hands. So now we're going to make fractions. The P over Q's are 1 divided by 1, the positive and the negative. 1 divided by 2, the positive and the negative. Now, is this on your test? Yes. Is it multiple choice? Yes. You need to be able to do what I just did. Make your P's, make your Q's, make your P over Q's. There's the answer. And this is a very small piece of this big problem, so it looks a little funny being the small piece. So let's do this one. P over Q's. Here's my P's. Plus or minus 1, plus or minus 3. Here are my Q's. Plus or minus 1, plus or minus 3. Okay, P over Q's. So shake hands and make fractions. 1 divided by 1 plus or minus 1. Those are the factors. Okay, we're going to do another example. Hold that question. Okay, I will cover that question. 1 shakes hands with 3. Plus or minus 1/3. Three shakes hands with 1. Plus or minus 3 over 1. And 3 shakes hands with 3. Plus or minus 1, which we have a duplicate. We're going to take that one out because we already did it the very first one. Okay. How did I get the 1 and the 3? These are the factors of 3. Factors of 3. For example, okay, how about this one? 2x squared plus 11x plus 5. I want the possible rational factors. So P's, these are the factors of 5. So we have plus or minus 1, plus or minus 5. Q's, factors of 2. Plus or minus 1, plus or minus 2. So now P over Q's. 1 over 1 and 1 over 2. 1/2, right? Okay, now we're going to have plus or minus 5 divided by 1 and plus or minus 5 divided by 2. Okay, now we did this problem. We did factor, split, and solve, and we got -1/2 and -5. So x is equal to -1/2 and -5. Can you see that it agreed with my prediction? Yes, you divide every P with every Q. Okay, so it's a longer, harder, worser way to find these zeros for that polynomial. But when you get to math analysis, they're not going to look like this. They're going to look like this. So this method helps you to find the zeros for longer polynomials than the ones we're doing this year. Okay, it's not that bad. I'm not saying don't take next year. This is just a little tool that's going to help you in your future math classes. And it's not as bad as it looks. Maybe long, but not bad. Okay. So right now you're just doing multiple choice, identify, put all the P's over all the Q's, and pick it out of multiple choice. Yeah, doable? Okay. Solve using long division. Okay, sorry I keep doing these extra ones. Solve using long division. So what if we wanted to do this? Solve using long division. Actually, let's change this to 12. Do you know what the answer is going to be? Okay, long division. There's a 4 in there. That's a good guess. Okay, so remember your long division. Step 1, make it match. So I want this to be x squared. How do I make it match? I put an x right there. So step 1 is make it match. Step 2 is multiply. X times x is x squared. So I took the x and I multiplied it by the x. I also have to take the x and multiply it by the what? by the 3. X times X is X squared. X times 3 is 3X. Make it match. Multiply. The next step is subtract. With a different color. Distribute the negative all the way across. X squared times X squared minus X squared. Bam. Disappears. 7X minus 3X. 4X. Okay, does anyone have a guess as to what the next step is? Bring it down. And repeat. Make it match. What needs to go there? For X. In order to get a 4X, what needs to go there? Four times X is 4X. 4 times 3 is 12. Make it match, multiply, subtract with a different color to make sure you remembered to go all the way across. Okay, where is the answer? X squared plus 7X plus 12 divided by X plus 3 is, where's the answer? Yep, X plus 4. Could we have done that by factoring? Yes. Take X squared plus 7X plus 12, divide it by X plus 3, and you get an X plus 4. Okay, now let's do long division. Carefully copy them down. Okay, 9m to the 4th, 26m cubed, 33, 31, 12. Divided by m minus, oh, yeah, m minus 4. Okay, what's step 1? Match. Yeah, make it match. So 9m to the 4th goes there. So what needs to go up there? Nine m cubed. Okay, multiply. Nine m cubed times m is 9m to the fourth. 9m cubed times -4 is negative 36m cubed. Match, multiply. What's the next step? Does not start with an M. Subtract. With a different color. Distribute the negative all the way across. Nine m to the fourth minus 9m to the fourth, bam, 0. Negative 26m cubed plus 36m cubed is positive 10m cubed. Bring it down. Okay, back to the top. Make it match. Looking for this number. M times 9m squared will equal, oh my gosh, 10. 10m squared will equal 10m cubed, right? 10m squared times n will be 10n cubed. Multiply. 10m squared times -4 is negative 40m squared. Next step, subtract. Bam, those are gone. 7m squared. Bring it down. Minus 31m. Okay, make it match. 7m squared. And how do I get that? By multiplying by 7m. 7m times m is 7m squared. 7m times -4, negative 28m. Subtract. 8, 9, 10, 11. 3, negative 3m. Bring down the 12. Make it match. M times -3 is negative 3m. Multiply. -3 times m is negative 3m. -3 times 4 is positive 12. Subtract. remainder 0. We are done. Okay. Now, there's another way to do this called synthetic division. So we're going to do this one with synthetic division. Will this be on the test? Yes. You need to know how to do long division on the test. Now there'll be one with long division, one with synthetic division. Okay, everyone, if you're feel like you're dying right now, you're going to like synthetic better. I promise. So tune back in. So this is what you do. Take the coefficients. You don't have to write this down because we're going to do a synthetic one in just a minute. Okay, take the factor of m minus 4, change it to a 0 of positive 4. Basically, you're changing the sign. Okay, I promise you're going to like this better. Yeah? You believe me? Watch this. Bring it down. And I'm just don't try to write this down, yeah? Multiply, add, multiply, add, multiply, add, multiply, add. Bam! It's a shortcut to long division. But where the heck are the answers? So this started off with m to the 4th. So you take it down a level. 9m cubed plus 10m squared plus 7m minus 3. Magic. Got us the same answer as long division. Nice, huh? Little bit nice. Yeah. So you, okay. You need to know how to do the long division, but synthetic division, bam, done. Okay. Synthetic division. Okay. So now we're going to practice synthetic. You don't need to write that down. Now we're going to practice it right here. Ten times better. Yeah. Okay, let's do synthetic division. In the box goes -4, right? And making that negative, you know how in long division you have to keep subtracting? Making this negative is going to make everything subtract. Bring down the coefficients, make sure there is no gaps. 1 n to the 4th, -2 n cubed, -26 n squared, -11 and -12. No gaps. N to the 4th, n cubed, n squared, n to the 1st linear term. Anyone remember my first step? What do I do with the 1? Bring down. What do I do with the -4 and the 1? Multiply. Next step is add. Multiply. Yeah, do you see what I just multiplied? Does everybody see how I got that 24? Next step is add. Okay. What goes here? Yep. Anyone else? Multiply. Add. Multiply. Add. We're going to have a remainder 0. So it was n to the 4th. We go down n cubed. Remainder 0. Done. Okay. Box method, super cool, but I won't be testing you on it. Do not do. If you want to see it, it's really cool and it actually helps you understand the whole process of division, but we just don't have time. Okay, evaluate. You're going to plug this into here. This is on your own. If f of 4 equals 0, then n equals 0 is a root. So you're going to plug in n. Okay, hold on, Jack. We'll go back. I promise. We're going to plug in 4 and we're going to see if it is a 0 or not. Okay, general shape. Sketch. Number 20. What is it going to look like? Negative x to the 4th. We are ignoring all of that and we're sketching from the table, right? The negative. So that's kind of like fall left, fall right, some sort of bumpiness in the middle that I don't know. 21, sketch, ignoring all of that, just a sketch of the end. Oh, and we're not going to label the y-intercept. Rise left, fall right. But we know how to find the y-intercept, right? X to the cube, x cubed, fall left, rise right. X to the 5th. 1, 2, 3, 4, 5. There you go. And are we done? We're done. Okay, I will take questions. And Jack, you want to see, what is it? This one? You got to do number 19 on your own. And okay, so if you come out, if it gets 0, you're going to say, yes, it's a root. Number 10. On your own quadratic formula. Yes, you have to do it. Thank you for coming. Oh, can we do number 10? Yes, we will do it together if you want to stick around. Okay, any other quick questions? And then we're going to do number 10. Okay, let's do number 10. First of all, let's try to factor. Are there 2 numbers that multiply to get 4 and add to get 7? No. Okay, quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals -7 plus or minus. Simplify in here. What is, so this is 49 minus 16? 33? Yeah. Okay, now let's look at the number 33. Does 33 have a factor that is a perfect square that we can split? Nah, 33 is 1 times 33. 3 times 11. No perfect squares. Ya es todo. That's it. Okay, so you don't always hate quadratic formula. It's not bad. The first time you see it, you think, I'll never be able to do that. And then you realize it's not that bad. Okay, anything else? Number 19. All right, let's plug it in. F of 4. My brain kind of jumps. Okay, so this is 256 minus 256. Let me just see. I don't have a calculator. 4 to the 4th, is that 256? Yep, 256. Sorry, I was just super lazy and did not want to go running for a calculator. Okay, minus 16 plus 40 minus 24. Which is 256 minus 256 is 0. Negative 16 and negative 24 is negative 40 plus 40 equals 0. So F of 4 equals 0. If you plug a number in and you get 0, then yes, it is a root. Okay. Hold on, Jack, what did I promise you? Did I show you what I promised I would show you, Jack?
It was, oh, I just need to real quick see 23 and 17 was all.
Okay,
Just
there's
the answer.
23. And then Jareth, we'll go back and
Okay.
we'll look at 1 and 2. Okay, so 20 through 23, we're using the little table with the parent graphs. And what else, Jack?
17.
Okay. Oh, synthetic division. Okay, we good?
Uh, okay, 1 second.
Yeah. Okay. Next, I'm gonna scroll back up and we're gonna just look at 1 and 2.
Alright, I got it.
Okay. 1 and 2. No radicals in the basement. Here's the key right here. No radicals in the basement. You're welcome. Thanks for coming. Bye-bye. Bye-bye. See you next week. Thank you. You too. Bye. Thanks for coming. Thank you. Happy Valentine's Day. See you next week. Are we good?